Today I'm gonna study the WebGL program from Pixie, and I've been studying WebGL, but uh, let me wait to see if it's streaming, then I'll talk about it. Okay. So I've been studying through the site here, and shout out to the person that made the site because it's very good. But the issue that I'm having is trying to think about what is a good way to practice or to train. Because just reading the tutorials is very easy, the way that they do it, and to actually understand how to build it myself is a lot harder. So that's the problem that I'm having. And there's some parts on the tutorial that they skip, which is the parts that are most important to me. And one of them is building the sphere. But I think I'm gonna try to explain briefly the basics of it. And it's this repository here, the site. So what I'm gonna do is go over the WebGL programs and then maybe go back and try to build my own thing. But I'm not really sure if I'm gonna build it my own thing because of the way that it works. I think I'm just gonna use the PixiJS programs, and then I'm gonna build my own code to create the visualizations from the Pixie programs. I'm gonna use SkylyDraw to explain. It's very simple, it's not hard at all to understand how it works. Obviously, the hard part is building everything with it, so. And I made this spreadsheet here with the concepts. This part is the one that is also confusing. Like thinking about, in the tutorial they have the code and it's easy to see, but like thinking about how to do it on your own is kind of hard, on how to translate. But it's pretty much just, if you're doing with 3D, it's gonna be a matrix, and if you're doing with 2D, it's gonna be vectors. And then you're just gonna do multiplications on the matrix and vectors, and that's gonna change the positions of everything, depending on the multiplication you do. So I'm going over these steps here to see if I can understand more. But pretty much the way that it works is that you have the vertex shader and the fragment shader, and they're pretty much just functions. So it's just as simple as that. And then, because JavaScript can't communicate with the GPU directly, so you have these functions, and then you have a buffer, or multiple different buffers. Oh, actually, before that, you have programs, and the program is just the two functions together. It's as simple as that. So first, you build these two things here, which can be a script on the HTML file, or it can be a string in JavaScript, and it's just a function on the GLSL language. And I think GLSL stands for graphics something. I forgot the exactly what it means, but it's something about graphics and comes from OpenGL. So the way that it works is pretty much you have these two functions, and then the fragment shader is going to be responsible for the color, and the vertex shader is responsible for the position. And in both of these functions, you have two special variables. Like in the vertex shader, you have one special variable, which is GL position, and on the fragment shader, you have GL frag color. And it's through these variables that you decide what's going to happen. And then they pretty much serve as a template. So let's say you have actually you can only draw, as far as I understand now, primitives, which is very basic shapes, but I think it's just triangles pretty much, because the tutorials just talk about triangles. So I think that the way that it works is you have to build triangles on the fragment shaders, and then if you want to build more complex shapes, it's based on the data that you send. So, and so the way that it works is pretty much the function is a template, and then you create a program with that template, and then you create data and put on the buffer, which I think a good way to think about it is like kind of like a truck that is going to deliver packages through the roads. So the buffer is the truck, and obviously there is a limited amount, but you can send a bunch of packages by making a bunch of calls. But then you create a program, and then you put data on the buffer, and then based on the data you put, is gonna call the functions on the program. So maybe it's the other way around that it links. It's better to represent like this. Here I have data, and data is pretty much, depending on the type of visualization, is gonna be either a matrix or a vector. And the vector is going to have the positions, and then based on the calculations you do on the shader and the fragment, the vertex and the fragment, is going to determine what's going to draw. So yeah, that's pretty much it, the way that it works. And then it gets complicated because then, and this is the part that I'm struggling now to understand, is exactly what parts of the code should I put on the vertex and what parts should I put on the JavaScript code. And also what is the best way to go about doing the calculations to change the view and the camera and things like that. And I think that some of these, like the articles explain very well, but I don't understand really well. Just based on them, I have to do my own thing, so that's why I think that now the best thing to do is to just go over the programs on PixiJS. And also the other thing that they talk about, and I agree with, is that the other thing is you have to, every time you're gonna pass the data, you have to access the variable inside of the shader, and the way you do that is by making WebGL calls. So for example, if you declare this variable inside of the shader here, a position, which is an attribute, then you have to call this function, and then you access this variable, and then you use this variable later. So you create the buffer, then you use the variable, pass the data, whatever. But it's just a bunch of different different calls that's kind of redundant, and it's a lot of work to do it. So they talk about a library that simplifies everything and allows you to, like, it's kind of like a layer in between PixiJS and WebGL. Like WebGL is the most low level. Then you have this library that allows you to make the code with WebGL. And then PixiJS is like a higher layer of abstraction on top of that. But obviously, I'm not really sure if PixiJS uses the library here. It's just another layer of abstraction. So this is another thing that I'm debating, whether or not it's worth it to use this library here, or because I think, and this is the thing, I have to see how PixiJS does it, because I want to build from their stuff. And also I realized that the title of the streams are not very accurate, because I'm not trying to rebuild entire PixiJS. I'm just trying to rebuild it based on the stuff that I'm gonna need. So maybe it's a little bit misleading, but like there isn't a better way, I think, to describe. Because I think it doesn't make a lot of sense to put trying to rebuild a part of PixiJS. So but I'm not trying to rebuild everything from PixiJS. The point is to just try to remove as many things that I'm not going to use, because PixiJS is more general and it probably has a bunch of stuff that's not necessary for my use case. So Just wanna see how I can build with the least amount of code. And also there is a bunch of stuff talking about this resize here, which is very confusing. Not very confusing, but it's very annoying that to deal with this kind of stuff. But they pretty much recommend you to use client width and client height instead of accessing width and height from canvas, because of some stuff about the pixels and the different devices. And then you have to set this because this allows you to keep the ratio, I think, to convert from clip space, which is the space that WebGL uses. So the coordinates of WebGL are always from -1 to 1. And then the coordinates of the canvas are obviously in pixels. So you have to convert both of them. So it works, and this function here does that. And there are other calculations that it does on some tutorials where it gets the resolution and then divides stuff by the resolution. It's pretty much trying to normalize things so that they are in the correct coordinates on WebGL. And this code is not 100% correct because I changed some things here last time. So the way that I'm doing now, and that I wrote this down here because I think that this is a good progression of things. And I thought about like, what is the best way to learn? It's probably to build something. So I was thinking about what can I build that is not going to be too hard, but I couldn't think about anything that is like very simple but is not very basic. So I did these challenges here. And this is the stuff that I'm kind of struggling with now, because this challenge is very easy because they already provide all the code. And it's not that interesting. You just pass the data, you just change the positions here to change the shape that it's going to draw. These positions, because this is pretty much the data, is a vector, and then you're passing this as a float 32 array to this buffer here, and then on the draw you call these functions, which you use the program, and this one draws the data you pass to the buffer. And this here is also a little bit confusing, but it's pretty much the specifications that I have to pass to the shaders to determine how they're gonna draw this stuff. But this is a part of the tutorial that I didn't like very much, because, and this is the stuff, like, because the tutorials are very good, but they, on these nuances, they don't explain. They just put the code, so it's kind of hard to figure out what is the best way to think about it, so I can build it on my own. But pretty much if you want to draw a different shape, you just change the data here, and that's the way that it works. So it's like you create the shaders, which are the templates, then you specify how you're gonna structure the data, and then you pass the data to the buffer, and the buffer calls the program which has the shaders, and the shaders are the stuff that communicate with the GPU, and the GPU does the calculations. So all the WebGL is just a rasterizing API, and rasterizing is just a fancy way of saying drawing. So it just allows you to draw stuff with the GPU. And if you want to build more things, then you have to do the calculations. So, which are kind of annoying as well, to be honest. And also there's something really annoying as well about this that they explain, but I didn't quite understand very well. But it seems like the calculations that WebGL does with matrices are different than normal mathematics. So they swap the rows and columns. So in mathematics, the rows are horizontal and the columns are vertical. But WebGL, it seems like they switch because for some reason, which is kind of annoying as well. Yeah, but I think I'm gonna go over the files here on PixiJS one by one, because on the last stream I took all of the files that I think he uses during the process of initialization of the application, and then I separated here to the ones that have the programs and the ones that are just used for systems or for managing everything. I think I'm gonna close all this stuff for now. And maybe I'll show this. So this is a function that creates the shader first. So first you create the string, then you call these functions from WebGL, and that's gonna create the shader. And then once you have the fragment and the vertex shader, you pass through this function here, and then you call these functions on WebGL, and it's gonna create the program. And then you use the program with the buffer data to draw stuff. And the challenges that I was thinking about that I thought would be really interesting to do, but might be very difficult, so I might not do them, is the one is create flowchart representing WebGL concepts. So pretty much create a graph network that represents WebGL. And the other one is to create music resonance pattern visualization, which is pretty much being able to see, and this one I think is very interesting, and I might do this in the future, but I'm contemplating whether or not it's gonna make me deviate too much from what I'm doing now. But pretty much is you take a wave from you take wave functions from music, so the patterns of the sounds, and then you create a simulation that shows you the visualization of the geometric patterns that the music creates. And there are some videos on YouTube that shows this. They put the vibrations on a, I'm not sure what the name of that is, like a metal or something like that. And then they put a bunch of sand, and then based on the sounds of the music, it creates geometrical patterns. So I thought this would be really interesting because it would allow you to... Then I thought about if I can use the sound to create the geometric patterns, then I can start organizing music based on the geometry instead of the sound, and then seeing if from the geometry you can create different sounds. And I thought that would be really interesting. So pretty much you get the data, and from the data you pass into the buffers, and then obviously I would have to determine like basic geometric shapes that would change based on the data. I think that might be, but it might be too hard to do it. So, and this is the function to change the size of the canvas. And there's a lot of stuff that they talk about there. Maybe I'll read the tutorial later today. I think I'm gonna read all these tutorials. So the plan is to go through PixiJS, read all the programs from PixiJS, then come back to these tutorials, read the tutorials, and go back and forth until I understand how it works. And then after that, I'm gonna see what are all of the parts that I'm using from PixiJS, all the classes, the systems, and I'm gonna try to just build the stuff with the systems that are essential. I also have to change all of them because they're online. The other one already changed, so I have to put like this. Also change the string format here. See if the other one is like this. So the part that is hard to understand, and I don't remember seeing when I was going over with the debugger, is at what point they use this. I think on a couple of functions I remember seeing this, and I think I wrote down on the flowchart the specific parts that they use the strings to create the programs. But the part that is hard is when I'm actually drawing this stuff, how do they use them? And also how does it work with the different coordinate systems? And there are some articles here about that. I think one article, it's called Matrix Stack, I think. And I think that's how PixiJS works, where like for each for each container you put in Pixie, for each class, you have different matrix. And then from those matrices, they are all connected based on the hierarchy you put on the app. And then each time you do a transformation in one of the matrices, it automatically calculates the transformations on the other ones. And that's the part that I think is the hardest to understand. Like, I think it's not hard to understand. It's very easy, the mathematics, but the problem is when stepping over with Pixie to extract all the information that is relevant. That's gonna be annoying. So maybe it's not, maybe it's worth to try to do it from scratch without thinking about Pixie at all and just, yeah, because I think there's a lot of stuff from Pixie. Most of the library I'm probably not going to use because it's not related to what I'm trying to do. What I'm trying to do is pretty simple, I think. So I can simplify a lot. And I think it's much better to go about it this way because complexity adds itself naturally. So it's always better to try to simplify as much as possible because everything is going to become complex later on eventually. And if I'm using PixiJS, then it adds a bunch of different, a bunch of complication that I don't need. I think I'm gonna be right back. So the hard part is understanding like, how can I build the simplest program with these things here. So obviously I can I'm gonna copy these files and put on the other project here, and I'm gonna use those files to create the shaders. But then how does PixiJS create the program? I think that's the questions. So how do they structure the program? And I think I can figure that out based on the variables here. But also maybe I'll have to step over. Let me think about it. Because I wanna understand what... I think what I'm gonna do is just get the classes that I'm using there, that I'm calling, and I'm gonna see what kind of stuff they have and try to get only those things to do the calculations. But I need to figure out what exactly happens when you draw something or when you change the position of the container. Because the way that I think it works is you change the container, and then based on that, you change on the Pixie class, the Pixie class has its own state that maps to the state on the WebGL and on the WebGL program, and then it changes the state of the PixiJS class, and then based on that, it calls the program again. But I don't understand really well how it works. Also, I think the biggest issue is the rendering cycle, which is the request animation frame, which PixiJS uses a ticker. But from what I remember, just stepping over it, it doesn't show anything related to WebGL, so that's the problem. And the issue is that if I'm gonna do it without using Pixie at all, then I think it's better to use the library here and read the API and stuff, all the stuff that it has. Because most of the calculations that are just annoying, is like there isn't anything interesting, and I think you can't really do optimizations just by changing the code, so it's much better to just use their library that already has all the basic calculations and try to build it from that. But obviously PixiJS is gonna do it in a different way, so I have to understand how they do it, so I can try to mimic or copy as much as I can from the way that they do it. I was pressed on the wrong thing here. So they're using position, color. Oh, and this is stuff as well I have to remember. The definition of the things, which is kind of hard. I don't see any other way to study this other than memorizing. So attributes, only available to the vertex shader as variables typically used to store color information, texture coordinates, and data that needs to be shared between JavaScript code and the vertex shader. Variance declared by vertex shader used to pass data from vertex shader to fragment shader, commonly used to share a vertex normal vector after it has been computed by the vertex shader. Uniforms set by JavaScript code, available to both vertex and fragment shaders, used to provide values that will be the same for everything drawn in the frame. For all vertices of a single draw call, lightning positions and magnitudes, global transformation, and perspective details. So I have to remember which one is which. So here they have a bunch of attributes, these uniforms, translation matrix, obviously used to translate probably. The color, vertex, V texture coordinates, color. So they do the X and Y. It's interesting that here is X. Oh, but they're both X and Y here. It just changes the sign that it uses. And then obviously sine and cosine are used to rotate. And it's based. They advise you to do with radians because it's easier to think about. So radians are in terms of pi, and the pi determines the rotations. And gel position here. Also, I have to see what library if they are using any library. If I remember correctly, they create the classes which have a bunch of information. So they are not using a library like GL matrix to do the calculations. But maybe they are. I don't remember on the low level, like on the base class, the matrix class. Maybe I'll have here. Probably I do, yeah. This one. Yeah, so they just create this class here. And then I probably do the calculations based on this class. And this is what I have to think about, because I think I wanna do things another way, so like what is the most efficient way to know exactly what they are doing, what they are using here for my thing, so I can just remove everything that is not necessary and just do the calculations that I have to do. The other thing that I didn't understand very well from the tutorial is that it has these other variables here, and I didn't. In a lot of examples on the tutorials, it has other variables as well, but it doesn't explain how the shader perceives this. Like, because obviously you're gonna change the value of these variables based on JavaScript code, which is gonna be the data you pass through the buffers that are gonna change the values here. But then how exactly does the GPU know what the variable means? How does it decide to do the calculations with this? It just talks about the GL position and the frag color, but it doesn't talk about the other. It doesn't explain how the other variables work. It just, as far as I can remember, maybe I don't remember really well, or I didn't pay too much attention, but I think I did. And also this XY here is kind of a, I think it's just a property of the vector, and it's gonna be the thing that it depends on the index of the vector, x and y. But it doesn't explain this very well. How does this work? So I have to see if it's possible both to simplify the programs as well. But I think probably it's not worth it to simplify. It might be possible to simplify because the stuff that I'm trying to do is not as general as the stuff that they do. But I think that it's not gonna be enough of a difference in efficiency or memory to worry about changing the program itself. Just reading here, trying to understand, trying to think about how this is going to be used on the systems later, so I can understand what should I look for to change the library. think maybe probably the best thing to do is just try to use these shaders and try to build something simple with the shaders. Then go back and step over Pixie. Just see how they design the systems or the classes to manipulate these programs. I don't understand why this has a new line. I think I'm gonna go like this. Maybe shouldn't be doing these ones because they are related to pictures. If you wanna draw pictures, and I just want to draw the shapes. I think the main thing that I want to do is draw the circle, but it's hard to understand how they do it. Because if you can only use triangles, how do you draw the circle? Obviously it's gonna be an approximation, but in the tutorials don't explain this, they just use a library. And then from the code that I was trying to reproduce from the tutorial, you call a method on the window that gets the buffer for the circle, but then I got a complaint there, and like it looks like the method is not working on my thing. So this is the part that I want to understand, how to create the data, which is just an annoying thing. It's not that interesting. It's just going to be formatting a data structure to have the positions in such a way that it's going to form a circle. But it is very difficult to think about. And here it seems like it doesn't have anything that is related to WebGL. So obviously it could be this. It's gonna be this, but then how does Pixie translate the code from outside to there? I think I'm just gonna open the other project and go over with the debugger. But I'm not really sure if that's a waste of time or if I should just look into how to do a circle in WebGL. and then I should do my own thing. Lines, I think, are very easy. And then circle is kind of hard. So I'm gonna go over these programs here. Not gonna reformat the other ones because it's probably not that interesting to what I'm trying to do. Maybe texture. I think actually I'll do texture and then I'll go over the programs, and then after that I'm gonna stop over. Because texture is probably used to do the labels. Let's take a look on the programs. So yeah, like I said here, you have this true. You have the strings, which are the shaders. Then from the shaders you have the program. And then the other piece is the data. And then the translation is gonna be changing the matrices on the program. I guess this is one part that is confusing, because the program is just going to be two functions for the vertex and the fragment. But then the question is, how do you decide how many programs you're going to use, and how do you decide how the programs are connected with each other? I think this is a part that's kind of confusing. So I have to see. That's the part that is difficult to think about. Because based on the articles, the way that they explain it, like the program is going to be related to the stuff that you're drawing. And then on the program you have matrices that are representations of the way that the world is going to be. I guess the way that you do it is just you create a program that represents the world, and then based on the data you decide what's going to be painted. But thinking about the structure of how to structure the program in such a way that you're going to have this connection of concepts here, that's the part that is hard to understand. I think I'm going to spend some more time looking at the Pixie code, and then I'm going to read these articles again. And there is one here that explains this structure. Which one is it? Is matrix stacked or something like that? Yeah, this one. And there are also some really good tutorials that have the code where they show, like they have the code that allows you to put sliders and change the visualization based on the sliders, which is very nice, because I can pretty much copy that code now. That's gonna allow me to change the visualization. The only difference from what I'm trying to do is that obviously my sliders are also gonna have logic to change the physics. So I think for visualizations I'm not gonna use the sliders. I'm just gonna do the keyboard bindings. And the way that I'm thinking about is to be able to select each node based on the keys, so you can navigate the graph with the keys. It's a lot more efficient. But I need to master the process of changing the camera of the visualization. Because another thing that I think would be really nice to have is something that allows you to put a function on the key that after you pass the key, for example, you press enter, it starts an animation that traverses the graph and explains everything that is happening. So like you can imagine that, for example, I can simulate the execution of a script based on a letter or a key. Not sure what's the right name. Is like a keyword or a key from the keyboard. So let's say you press enter, then as it navigates through the visualization step by step, it goes over the nodes and then it explains what is happening on each node and maybe do some highlighting on the graph. But obviously to do that I have to master how to change the visualization, how to move the camera around, and how to change the elements as I move the camera. And I think that the way you do that is pretty much structuring the program and changing the data based on the inputs. But it's very hard to think about how PixiJS does that. And this is the reason why I'm thinking it might be better to just do it completely on my own and forget about PixiJS. I think that might be better, because it feels like it's gonna be harder to just break this stuff down to figure out exactly how they are doing. But the problem is I don't wanna do like every single thing. So maybe I can just use all of the... I have to figure out exactly what are the programs that they are using. I think that's the next step. And then based on exactly what programs they use, then I put those programs on a file and then I use those programs to create the visualizations. Because I think that's the most annoying part. Not only their programs, but how they are structuring the data to create the circles. And also the structure of the world. But this might be better to just get from the other tutorial on how to structure how to move the camera around and stuff like that. think I'll be right back. I'm gonna just quickly look. Next, I'm just gonna quickly look over all of these files. And then I'm gonna step over. I'm gonna open the other project. I'm gonna step over Pixie. Just see if I can figure out exactly what programs they are using. Maybe I'll write down the questions so I have like an order to follow of the stuff that I wanna figure out. And then once I extract that information, I think I'm gonna try to build it from scratch with the other tutorials. So mix the code from both. And then go from there. So I'll be right back. So a lot of the code might be here as well. Which is a problem. Like it might just be better to just do everything from scratch. Like maybe I should, after this video or after this stream, I should just do like another name and create another playlist, and then just try to build everything on my own using the other library here, this library here, because it might just be a waste of time to try to understand everything that they are doing here. And just based on the other code that I saw from Pixie, it's not the way that I like to think about this stuff. I think a big part of the reason why is probably because like the library is not for what I'm trying to do. It's a lot more general. It's probably designed more for games. So a lot of the way that they designed is not aligned with what I'm specifically trying to do. So it just seems like a waste of time to try to figure out exactly what I'm gonna need and what is all of this stuff that is kind of redundant, but at the same time, like, it's gonna be very difficult, I think that the part that is the most difficult is figuring out how to translate and shift out the elements. And I think I have a much better understanding now of the connection between the physics engine and the visualization. Like, the coordinates of the physics engine are going to be dependent on the class you create the visualization from. And each class, I think, it has its own coordinate systems. And then there are probably some calculations to translate everything. But to deal with both of them, the video from that guy is very good. And I think it works for any case. Because it's just going to be a simple translation or rotation of two different world coordinates. And that's all we have to do to synchronize the physics engine. But the question is how to structure the connection between the different visualizations. I think that part is the hardest. And also the other thing that I have to think about is what is a good way to... Maybe I should just build this stuff here. That might be a better thing to do now. And just search everything that I get stuck at. So I'm probably gonna read the documentation for the other library, because there's a lot of code that is redundant, and it's probably better to just separate that code into specific files, so I don't have to deal with that bullshit all the time. Just getting the variables, creating the program, stuff like that. And once I get to that point, I think about it. So what are the questions that I have? I think the main one in my mind right now is how to go about the thought process of structuring the program. And if you should have a program for handling the entire world, and like the connection between different classes, I think, is the one that is the most difficult.
Your life isn't a problem to solve, but a reality to experience.
I think probably the programs mimic the classes structure. At least that's what makes more sense to me now. So they probably have different programs that are related to different things, obviously. But then, like, how do you decide the connection between them? Because if I have a program that is handling the world coordinates, then how do I make it so that when I change that program, it's going to change all the other ones that are dependent on it? I think that's the question. Maybe going over the tutorials is probably the best thing to do now. Just try to build try to go about solving the challenges there. I think I'm gonna read the documentation for this library here, and then I'm gonna try to incorporate this library. The issue is that, like, because then I'm not using Pixie and using another library, so, and this one is gonna have obviously a bunch of stuff that's not necessary as well. I think it would be ideal if I could only if I could simplify only this stuff. Maybe I should just do everything from scratch, and then the stuff that I find repetitive I put on different functions. But the thing I think I'm confused about is the one, yeah, I think this one is like, I didn't understand very well how they recommend to simplify the variables, because you always have this structure here where you have to create have to call this method for each variable that you use on the program, and it becomes very verbose. So, but I don't understand like the way that they recommend. It seems very confusing. Like they create these objects, and then they create other properties on these objects that are like it's gonna be an object that has keys and values, and the values are objects, and then these objects have lists, and it becomes very like difficult data structure to deal with all these matrices, and it's kind of hard to think about or to understand how they recommend you to go about it. Because the other point of confusion is these things you have to specify to run the program. The number of components. It's not difficult to understand, but it's difficult to think about on the context of the bigger visualization. How should you structure everything? I'm probably stepping over Pixie's better first. So remember, the biggest, like most annoying parts of stepping over Pixie is that there's a bunch of stuff that is just annoying, like the configuration of everything. And then it's hard because you can't really skip, like you can't run because then you might miss something. Maybe I'll go back to the flowchart there and then see what are the parts that are related to the creation of the programs. And so it's on the plugin system, on the init, batch render. Shader generator. So they have the projection, the translation. And the other thing is that Pixie is just 2D, so it doesn't have the all of the matrices that 3D use. So this is another question that I have, is whether or not I can build this stuff for 3D, but then just make it 2D based on the calculations that I do. Because that would be easier, I think. Because the physics engine is 2D and they have 3D as well, but probably the 3D version is more complicated, so ideally I would be able to solve for 2D first, and then I think about the 3D. But I do want to do 3D visualizations as well. I think it's very interesting. See. Ask some questions to ChatGPT. I think these variables, they come from the, or they are passed around from the vertex to the fragment, because they're varyings. So maybe that's how it works here. So you pass the data on JavaScript, and then it's going to change the values here, and then these values change the fragment. They're passed to the fragment. And texture coordinates, a new color. On V color is this one. And then how is this used on the... Because I remember stepping over Pixie and it doesn't show anything about WebGL, I think. When you go over the drawing parts of the cycle. Like this part here. It uses the graphics and then draws. I'm gonna forget the graphics. Yeah, I think I didn't get it. So this is similar to the one that I have there. It just creates the shader based on the type is gonna be the string, I think. I'm not sure what source is though. Maybe I think those are the functions that are probably I was looking for. So I think I just have to copy these ones. So what they do, I think, is they're just gonna get all the variables inside of the program, the uniform and the attribute variables, and then this function is gonna create the program. And they have a class for this. I don't understand why. I think the class is not necessary, probably. Or you can just return the program. And close these other files here. I think I'm gonna copy these files that Pixie has to build the program, and then I'm gonna try to use these files to build from scratch. So I have to set up in such a way that it allows me to the way that I have to structure is just like a folder that is gonna contain the strings that are gonna be the code for the program. Maybe I'll put everything on the same folder. Then the functions that are gonna create everything, it's just gonna simplify getting all the variables and stuff like that. And then the main function is gonna be, maybe I should separate the data as well. I'm not really sure. Because the main thing that is gonna change, depending on what you wanna do, is the data. So I think like you have the template, which is the program, and the strings that make up the shaders. And then you have the data. And then based on the way that you structure your algorithms to change the data or to shape the data, you do a different visualization. So you have, it's kind of like model view controller. Yeah, I think that's exactly the paradigm, probably. The controller would be the thing that decides what shaders are used, what programs are used. The view is the data, and the model is the data. No, the view. Yeah, the view is the stuff that WebGL does, calculates. The model is the data. I think this stuff here is the specifications, maybe. No, GL get attribute location gets the variable, and then it passes the program and the variable name. So total attributes is gonna be an array with all the attributes on the shader on the program, which comes from the shaders. And then loops over all of them, gets the attributes. So it's gonna map the attributes based on name and the data. What else? I'm trying to think, like, trying to make sense of all of this to see what is the best way to go about it. Like, how can I mix the two different libraries that I have there to do this stuff? Because here I have similar functions from the tutorials, but they are they're more simple. And then you have the other tutorial here, which explains how to simplify, but they do it in a different way, I think, as well. So I have to clarify what's the difference between them. Probably I'm gonna use the one from Pixie. And let me compare the shader is mine. Yeah, mine is a lot more simple. And I think the reason why is obviously because they're automating the process of getting the variables, which is very annoying. But I'm trying to think about how do they use this later. So trying to understand what is the purpose of this thing here, and how are they gonna access this object here. I guess they're gonna know what are the name of the variables because they created the programs, obviously. So depending on what thing is gonna be drawn, it's gonna call the name, and then the map has the data. But I don't know how this is used. I think this one I'm not gonna use as well. Just gonna build. I wanna do something like this, where it just returns the program. Okay, let me see. This is, I think, a variable that you set on the fragment shader. I don't remember really well what is, obviously is the precision, but well, what exactly does it do? Also have to remember, like, I think the tutorial doesn't do a very good job of explaining of why does it call this stuff here. So I have to go to the documentation to search for these methods here. See what is the difference between them. I think I'm gonna go over the article again, and then I'm just gonna copy these files here or into the other one. I'm gonna copy them here. Just compile shader, generate program, default value, uniform data. I just want to set everything up so that I don't have to do the code in the beginning. I think that's the first step. And the second step is figuring out how to use this stuff. I think that this is the part that I'm stuck now. I probably have to go, but I have to think about a good way to like understand that without wasting a bunch of time going over stuff that doesn't matter for this. So I want to figure out, maybe I should go back to the tutorials as well and read this again. Like what's, because this is going to be the uniform, so it creates a map between the uniform name, which is the variable name, and this stuff here. So this stuff is probably the variables that are used when you create a program. I think that's the key here. So instead of manually putting, for example, you have count, which is the amount of times you want the shader to run. And you have to specify this as some method of WebGL. So instead of specifying each one manually, obviously, they create functions that automate this. And then it puts everything on a dictionary here. So I think I understand it now. Kind of. So you set everything up with these functions, and then you just call you just access the dictionaries to pass this stuff through when it gets time to run the program. So the other thing that I have to do to understand is how they structure the data. So I think at first how to create the program, then do a small list here. How to create program. Then how they structure the data. I think once I have it's because how to structure the data so that you create the shape that you want. Then once I have that, create algorithms to change the data based on what kinds of visualization I want. But maybe it's better to, before step 3, I figure out how do they manipulate the canvas? How do they manipulates the view. What programs are used and how are they connected? I think this is the hardest part. Probably this part is the one that I'm stuck now. It's understanding how what programs they're gonna use should change the visualization, the camera. But maybe they don't actually, because it's 2D. Yeah, but when you, I think that's how it happens actually. So each class is gonna have their programs, and the programs are gonna have the calculation for the positions. And then every time you shift because when you're dragging the canvas or doing the zoom, you're just changing the X and Y of the container. So probably what's happening is you're just changing like they're creating the vectors and then they are running the shaders again, but with a different, like after performing translation. But so the part that is hard is understanding how do they link. How does PixiJS links different containers with each other through the shader programs? I think that's the thing here. That's the hard part. That's what I have to figure out. But first I'm gonna figure out this. I think this one is those functions there, so it's kind of easy. Now I'm gonna see if I can figure out the data. Then I'll go over the next one. Right back. So I think I already understand how they, because I remember going over this, how they changed the container. But the problem is, if I remember correctly, it doesn't show anything on the shaders, and I think it's probably just because of the way that it works when it's running the application, where the shader kind of happens under the hood, probably. But this is the issue, is that the way that I think is gonna work is gonna access the x or and y variable of the container, and then it's gonna call some functions that are gonna perform calculations on the transform class that the container has, and then or the display object has, I think. And then based on those calculations, it's gonna change the visualization, but it doesn't show how those calculations change the access the shaders, and how the shaders are connected with each other. So I think probably what I'm gonna have to do is just go from scratch and just use these functions on the simple, like on the, to create the program, just try to use the Pixie functions. And then based on that, after I create the programs, then like I have to see how to structure the programs in such a way that they're gonna be connected through this hierarchy of classes. But the other thing that I was thinking about, but this is like if I want to create visualizations that are more advanced, but it adds a bunch of complexity, is that obviously when you introduce this connection between matrices, it introduces a cause and effect relationship between things. So you're putting the assumption of cause and effect relationships based on the way that you structure the hierarchy of classes. It might be the case that it is just a property of spacetime, and this is the reason why it is that way. Object classes are that way, because they're just exemplifying the cause and effect relationships that happen on spacetime. So the base class is more fundamental, is more the cause, and all the other classes are on the effect, and then every time you change something on the base one, it's gonna have this cascading effect on everything else, but the other way is not true. And that assumes the arrow of time. So like the tricky part about this is that if you want to visualize something that is more, if you want to change the connections you create, then you have to think about how you're going to structure the shaders in a way that is going to allow you to do that. And it's all based on matrix multiplication, I think. In the order you multiply the matrices, obviously, because the order matters. But it is kind of annoying to think about these things, because most of it is just very confusing, like deciding the positions of everything. And this is the part that's kind of annoying here, is like, how do I figure out which ones to use and then how I'm gonna use them? So I think I have to remember at what points those things are used, are the data for each one. Let's see if I copied everything that I need here. So compile shader, generate program, default value, get uniform data, get attribute data, map size, map type. I think these are all of the functions that are used. So now let me go back to the challenge that I did there, challenge 1. Maybe I erased. Yeah, I think I removed. But I probably have on the first program still. This is the code from the tutorial there, the one that they simplify. But it doesn't work because of this thing here. Yeah, here it also doesn't have the specifications for each thing. Or maybe it's inside of the animation. I think this is one big difference, is that they are using their own library to do the calculations for the matrices, and the way that PixiJS does it is with classes instead of functions. And I don't like that very much. I think I prefer this style here. But actually they are using classes, but it's more like an object with functions, but it's pretty much the same thing. But like I think that the thing that changes is the mentality behind it. It's kind of hard to keep putting into words, but like I think I prefer this way more. So I have to think about how to do it with this way, using the stuff from Pixie, because that's the hardest part, figuring out at what point they use each thing. But I think I don't have it anymore. Maybe on this one they still have it. Yeah, it's this part here. So it uses on this one vertex attribute pointer. So I think that these variables here are the same as the other ones here. Are these? So let me see. But maybe not. Maybe it's something else. You do have type, size. Doesn't have normalize here because it probably does normalize. It doesn't have stride and offset. But there are some other functions there that I saw offset. So maybe it combines these functions here with the other ones. Location. And here it does this before. Just gets here. Obviously, I'm certain that this function, the purpose of this function is to just simplify the process of getting all the variables. But I'm not certain about the nuances of it. So how is this used? I guess what I would do here, all I have to do is just... Oh, but the data is going to be an object, so maybe it's slightly different, but all I have to do is just access by name and then pass to this function call the data, convert it into... You pass the values from the object. And maybe it's just easier if I use the functions from the tutorials instead of using the ones from Pixie. Maybe you should just forget about Pixie altogether and just try to do it from scratch based on the functions in the tutorial. It's just annoying to figure out everything from Pixie. There's some function here. Yeah, I think this one has something about offsets. Yeah, data offsets. But obviously I don't understand how this one is connected with the other one. Uniform parses. So this class manages the data. So probably the graphics has this class and the other ones as well. I remember seeing that initializes the class at some point inside of the other ones. But the way that I think it works is it uses that class to structure the data, and then it passes to the programs that it creates with the other classes. Also, it's false by default. So this is the variables there. It's exactly the same. Interesting. First push buffer. So I'm trying to understand how is this class related to the other ones. Because obviously, from the stuff that I've seen there before, this class is gonna manage the buffers and manage the data for the attributes, I think. It creates the data, it doesn't manage the data, the state manages the data. But this manages the attributes, which are the variables and the buffers. Then the other class manages the data and probably communicates with this class at some point, maybe. Because it has to. Because the other one, maybe this one tells the other one how to format the data based on the attributes. And then the state one is gonna call the shader, the program, and then it's gonna run. But there isn't anything here that's like is a clear connection with the other one, so it's really hard to think about a good way to merge the two. I'm not really, because the thing that I'm concerned with is that I know that PixiJS probably has a bunch of different functions that already handle all the nuances, like cooling, for example, which is just deciding when to draw an object, whether or not it is on screen, and also manipulating the camera, and also dealing with the disconnection. So I think that PixiJS has a bunch of different functions that already do all this stuff, and then if I start completely from scratch with the tutorials, it might take a lot of time, depending on how complex these things are, to get it done. But then if I go with Pixie directly, it seems like it's gonna be a waste of time as well, because it's very confusing and it's gonna be difficult to see. Maybe it isn't even possible to see how the shaders are changing, or how it's calling the programs to draw. So I'm trying to think about what is a good way to merge the two. So I have to do the least amount of work possible while getting the most results. So I think in order to do that, I have to clarify the points of contact there with the stuff that I have already from Pixie. I think the main thing is understanding how these functions of get uniform data and attribute data, how is this stuff gonna be used? I think that's the main thing I have to figure out. So he uses this on the other ones. Oh, this also has set precision. I don't think I copied set precision. Yeah. I think I'm gonna create another file and start from scratch. So these ones are pretty similar, but I think the one that I have here is better. Because it has this extra stuff. But this one doesn't return the shader. Oh no, it does return the shader. It just has this. So I think I'm gonna use this one that I have. I'm gonna rename to compile shader. And then we're gonna delete this one. I'm just gonna pass this one here. Okay, so close this, close this. Obviously this one is much better than the one that I have, so I'm gonna use this one. Let's generate program, and the one that I have is now I don't remember, because this is not that one. I don't remember how I got to this one. Oh, here. Program from. Here. So it caches the string for the program and makes it equal to a program class. Yeah, but let me find the, I think it's this one. Yeah, so that's the one that I have from the tutorial. This one's obviously better. I have to understand this one. I think I'm not gonna delete this one, I'm just gonna use the other one. But I'm gonna leave this one here. And then this one uses the other functions. It also creates the program here. So I think, yeah, the difference is gonna be that I don't think I'm gonna create the program. I'm just gonna return. But I have to understand why they create a class. So attaches, links. The other weird thing is why does it create these variables here inside of the program if it's gonna return the other one. Like it returns this one, but creates the variables on this one. Doesn't make too much sense. So the only thing that would make sense is that it's using this program anyway after calling this, but then why have this function? But it is calling the GL functions for this one, so obviously it's gonna use this one. So what is... I think program is just... it's not an actual program. A WebGL program is just gonna be a dictionary that has the information for the vertex and stuff like that. So I think later on it's probably gonna use this program to... when it gets time to call the other methods from WebGL, it's gonna have on the dictionary. I think that's what happens here. So we're just gonna return this and not the class. But then I have to... because the problem is I'm not gonna have the uniform data. It's probably gonna be... it's definitely gonna be useful because it's probably the data being used to call the shaders. I'm just wondering how can I simplify this without fucking up everything. Because I'm pretty sure that most of this stuff, not most, but maybe some, is not necessary. I think that the way that I'm thinking changed a little bit as well, like recently, because up until now, the way that I always thought about, because I didn't know anything and I started learning while streaming, so I always assumed that people that were creating the libraries knew more than I do, and because of that, the way that they found to do things is the best way possible. But now I'm starting to change that way of thinking slightly, because I still think that it is very good to assume that, because obviously people spend a bunch of time trying to solve these problems. But like if you think about it, if AGI like was the best possible and reviewed all the code that exists right now, you will probably find like billions of ways to make it a lot more efficient. So, and it pretty much, the efficiency would be in compressing everything and also making things more simple. So the way that I think right now is that because we are human beings and because we work on things, the more you scale something, the more likely it becomes that there's going to be a bunch of things that are kind of redundant or not necessary. So it just adds a bunch of complexity that is not fundamental to the thing. And I think that's the essence of what I'm trying to do with the stuff that I'm trying to build. It's just how can you highlight what is actually necessary and what is just a bunch of complexity that doesn't make a lot of sense. And I think like the fundamental difference is that in what is fundamental and what is gonna change depending on like how this stuff was built. And the process of making things more efficient is simplifying. So figuring out what is the stuff that is more complicated than it should be, and then removing that. But obviously this is very hard to do. And it is hard to do because exactly what I'm struggling here with is that if you change something, then it might be the case that it was necessary, and then it's just gonna create more problems in the future. So, and this is the fundamental challenge I think with programming, is not whether or not you can do something, is what is the best way to do it. So, and the reason why this is hard is because there's infinite complexity. So like there's always different ways to do things, and the way you should do something is going to depend on the context. I think that's the fundamental thing. So you have an array of possibilities, and they're going to change with the context, and the context is infinite, so it's always going to change. So you're always going to have multiple different right answers, and those right answers are going to change on the context. And the structure of the stuff that you're trying to build should be correlated with the probabilities of the way that the thing is going to exist in space-time. So you assume like a degree of probabilities of how likely this thing is going to be used across these different domains, and based on those different domains, how they're going to evolve over time, and how the complexity of that thing is going to change, how flexible it has to be in relationship to that thing. So that is the most efficient as possible. I think the way you do that is just by, and this is the process of learning, I think in general, is just finding the multifractal structure, and it's always going to be related to density, because the higher the density of a multifractal pattern, the more likely it is that it will continue to be that way for a long period of time, because I think that's what time is, and yeah, that's what space-time is. So the compression of potential into patterns. So maybe I shouldn't use this, I should just change this function in a way that is gonna work with the one from the tutorial, the way that they recommend to do it here. Because I don't remember seeing these functions get called on Pixie, so I'm not gonna be able to figure out how do they use it. Because I have to do that, to figure out that, so I know like what is the point of putting this on an object, and also what is the point of changing. And I have to figure this out here, because this is gonna be the beginning of the script that I'm thinking about creating here. It's gonna be create the program first, and then based on that get the data, and then create the buffers, get the data. And do the visualization. Oh, so yeah, obviously I didn't realize that this is a static method, so because I remember this is called sometimes, so it just creates the class here and then it's gonna use this class. I have to remember how, but I think that's maybe I have here. I remember putting this somewhere. The state system, and these maps here. There's some part here that's I think I wrote down this state variable. I think it's this one. Oh, it's not this. This one creates the issue is understanding how the system is used. So the state system is going to be the thing that creates, but at what point it's going to use this? Because I think I should just stop over, just seeing if I can think about a better way, because I know it's going to be annoying as all. Just go over a bunch of stuff that doesn't matter. The other annoying thing is the context. But I'm gonna worry about that stuff later. I think doing with the articles here in the beginning, it shouldn't be hard, but then the problem is that the issue is the programs. It's how to understanding how to structure the programs and then how to manipulate the variables later so that it creates the stuff you want. That's the problem. So to create the program from Pixie, you have to understand the connection there. This is the issue. And have to understand how those variables are being used in other parts of the code. So obviously transform class is going to be the one that does the calculations for each thing. You have the bounds. But the thing is, I think stepping over is not going to show me the stuff related to the shaders. That's the issue. Maybe it is useful to do it this way, but I also don't like this very much. But maybe it's the same thing, because the other one is also a class, probably just an object with functions. But it seems like the feeling I have is that it's more complicated than it should be, I think. the matrix class. It's not so much the class itself. I think it's more about the way that everything is structured. I think that there's probably a way to do it that it would be easier to think about what's going on. But maybe I'm wrong because I don't understand really well how it works, obviously. Could be possible. I think it's not worth it to go over all these bullshits just to figure out. I think it's probably better to just try to do it with the articles in the way that they do it here, with the structure of the functions and everything. And then just copy the programs that I have there. Maybe I think I'm gonna skip to the point that it draws this stuff, because then I skip all the redundant stuff with the init and the context and all that bullshit. Yeah, I'll be right back. I think I'm gonna ask ChatGPT if there's a way. This is the main thing that I think it would be useful. Like if I could get the programs and the shaders that PixiJS uses, then I can use everything else from the tutorials, and it's gonna be easier because then I don't have to think about all of the way that Pixie handles everything else. So I understand the functions that is using there to create the program, and then I can start building from scratch. I think that's gonna be, because then automatically removes everything that might be unnecessary. But then I'm gonna have the extra work of figuring the stuff out on my own, which is gonna be hard, but I think I'm gonna learn a lot. So I think the main thing that I have to figure out is exactly which programs and because the programs are gonna be annoying to figure out on my own. Because the issue is that from the stuff that I've seen there so far, it seems like they use all those classes to manipulate a bunch of the variables, and each variable is going to be used on, like, different variables are going to be used on different situations, and then based on that is going to use different programs as well. So like the challenge is understanding how to structure the program or the shader in a way that is gonna work, but maybe it's not very good to use the Pixie ones because they might be more generic, which might be worst for the thing that I'm trying to do. So it might be the case as well. So it might be better to just do everything completely from scratch, but then it might take a lot more time. Let's put this remix that I always put. Oh, I didn't know that they have a debug mode. Interesting. Maybe this is gonna be... Maybe with this one I can see there. And I also think I'm not gonna use... Oh, the other problem is the ticker. I forgot about this. The ticker might have some... It probably does have useful things to handle the animation loop. This is gonna be annoying as well. Because obviously I can use request animation frame, but then... Like they probably design it in a way that it is good. Yes, let me think. What? Don't remember changing anything. Not sure why it's giving me this error. Oh, it's probably just because of the order though, but yeah, I have to import probably. Because I saw a stage there, so I thought it might be something with this stage. It probably calls that function and then it creates the vectors from this thing here. So I think all of that is doing is just putting the positions on the... Yeah, but the question is how does it work with the shader, because the shader only draws triangles, I think. So how would you structure the data? And this is the class that has the... So initialize this state to the other state class here. That is 0 in the beginning. Maybe it has to be that way, but I wonder if there's an easier way, a more simple way. 'Cause the way that they are doing is creating the hierarchy of classes to draw the geometry. And then they put a bunch of methods on each one to manipulate everything. But it feels like it should be simpler. That's the thing. For the stuff that I'm trying to do. 'Cause I think it would be easier to have everything in a function. And then that function creates the shape. Instead of having... Yeah, but either way, you probably should have a hierarchy of classes, because the question is how are you gonna handle the world and the coordinates. And the data, the variables, everything should make the drawing. Interesting. So this is probably an array that contains, like, is gonna determine the last part there when it calls gl draw array. I think from the articles there are just 3 main functions that the gl has, and everything else is just done to structure those 3 functions, which are the functions that are actually gonna draw stuff on the screen. So probably this class has this thing here, so that's at some point it loops over this and makes the draw calls. It's very complex. Let's keep going. And let's see if I can get the shaders and the programs. Then I'm gonna go probably try to use the functions from the articles to create the program and get the variables. Also, this probably adds to the shader. Yeah, adds a variable to the shader. It's gonna be this function here. And it's the function that I was looking at before. So it's just gonna store on this class here the attributes that it creates there on the initialization. So it creates the buffers and then adds these attributes here. So these are gonna be the data that is necessary to run the shader later. So now let me think, because the question is, should I use that or... Okay, is there a better way to do this than do it like this? I think that the way that it feels more intuitive to me is, instead of doing like this, I just set everything like, instead of adding to an array on the other class, I should just have a function, and the function has like mapping the function to the program that it's gonna use. I think that feels a lot more natural to me to think about it, because this way it gets very confusing. I think that's the problem, because this function is from the other class, and then it's gonna create this attribute there on the other class. Like, to me, it makes a lot more sense if you have the shader, and then because you know all the variables that the shader is gonna use, like you design a shader for a specific reason. So for example, drawing a circle, and then based on that, you know all the variables that you're gonna use, then you create a function that is gonna set everything up for the shader specifically. And then you just call the function and you set the variables based on the function. So the question is, like, obviously what I could be missing here is that because of the way that everything is structured, you can't really do it like that because of the connection between different programs. So I think this is the main fundamental thing that I have to understand. So maybe I should ask ChatGPT and then also read the articles again and do more research, because I think that's the key point, to understand how it works and how to simplify. Because depending on the way that you should connect different shaders, it might be necessary to do it this way, and the way that you're going to receive the data. So to me, I think it makes sense to make classes based on the data. So you make classes based, because the data is going to be dynamic, so it's going to change all the time, but then like you create a core set of shaders that you're going to use and a core set of programs. And then based on that, you create functions that are going to define everything for those shaders. And then obviously you can pass whatever variable you want based on the data. So the data is the part that contains the classes that is going to manage the state. So the flow is going to be from outside. Like you get some data somewhere, and then you have functions that structure that data. And then based on those functions, you set up the classes that are going to create the matrices that the shaders are going to use. And those classes are going to be the ones that contain the functions that set everything up for the shaders. So I think that the fundamental difference is on this part here, from the way that they thought about it. Because I think the way that they are thinking about it is more from, like, it's more connected, let's say. It's not only connected, but it seems like all over the place, the parts. And this is the problem, because I don't understand really well, obviously, so I might be wrong. But I think this is the issue, because like the way that you structure the classes, there are functions that should be like at one level, but because of the structure of everything else, they have to be on the base class. So like the parent class calls them, but they're on the base class, and it becomes kind of confusing. I think that's the issue. And then it becomes harder to think about, because it's like everything that you're gonna need to create the shader to run the program is gonna be scarce is going to be sparse along a bunch of different classes that are not necessarily designed to handle that thing. So like all the information is sparse. It's like distributed on all of these classes, but all of them have a different purpose, and it becomes confusing to understand. So I think that's the reason why intuitively I think there's a difference in the way that I want to do things, I think. Because the way that is easier for me to think about it is that if everything related to something is like encapsulated into that thing, so instead of having a buffer class, for example, I would have a function or a class that creates the buffers for that program specifically. I think that's the difference maybe. But maybe it makes more sense to do it the way that they are doing. It's very hard to know. So I think I need to spend a lot more time to understand. Yeah, I have to create a full program first so I understand more. But the main thing that I have to clarify is this connection. It is number 3 here, I think. It's tough because a lot of this stuff I don't know why they use it. There's a bunch of different variables on all of the classes, and they're probably necessary for something. But obviously because I don't understand well enough, it's hard for me to tell. Because it's very possible that, and I think it's very likely that the way they did it is probably better than the way that I'm thinking about right now, because I don't understand really well how it works. But intuitively, it feels that, to me right now, that it isn't quite right. And I think that this clarifies for me, like this realization that I just had, I think that's the fundamental reason why I have a problem with the way they did things. I think the main thing, and it happened all over the place, both in Pixie Viewport and in Pixie. The feeling that I get is that like there are a bunch of functions that serve a purpose, but they are sparse into different classes that have different goals. So that's the problem. Because the class is designed to do something, but this is the issue, because it might be necessary because of the way that the visualizations are done. So I think, like, for example, is that they have a class that is a circle, the circle class, and that class it does some calculations to create a circle. But the class by itself, it doesn't create a circle. It's just, it calls that class inside on another class, and then from that class it uses another class, and then it creates a circle from that. So I think the way that I think about it makes more sense to just like attach everything that you're gonna need to build the circle on the circle, and then like only separate the stuff related to shaders. So like do the uniforms, the data, everything inside of the circle class, and from that point just call the other classes or functions that are related to creating the programs or changing the programs. But I think that probably the reason why it is that way is because this is the challenge, is that like for their what they are trying to do is a lot more general. So there's a lot more things that can happen or that people can use the library for. So maybe that's the reason why it is set up in this way. And it feels off to me because of the way that the thing that I'm trying to do is a lot more simple. So it doesn't make a lot of sense for my use case to do it like that. Because even though it's going to be complex, it's not complex enough where it makes sense. But at the same time, I'm not really sure, because like the way that I'm thinking should scale as well, I think. Because you just compartmentalize and separate everything based on what you're trying to do. So I think the only thing that makes sense to have this like kind of more tight connection between things is with the world and the stuff that manages the view for each thing. I think for that it makes sense that they are connected, because you're gonna create a tree structure. Because if you want to put, you want to be able to decide what you're going to put at each level of the visualization. So, and that's the point of the container, I think. So I think that makes sense, because then when you translate the container, ideally you should have functions inside of the class that are going to determine how everything else is going to change. But then for drawing each thing on the canvas, I think it should be like only like one class that determines what happens. But maybe that's the way that it is designed here. It's just more complex because they have more possibilities of things you can draw, so they create more abstractions of the connection between these different classes here, because there are all these different variables and things you need. And so probably the way that it works is just through these variables. So it's like the containers are linked lists because of the variables, the attributes here. And here is the loop that goes over all the children doing the calculation through updates. Just gonna change the value on the transform. So I think the transform is the main thing that changes the actual shaders. Yeah, but it still leaves the question of how they are connected. I think it's not gonna show on the shaders what happens. I think it's just changing the X on the transform, but it doesn't show what happens on the shader. That's the issue. Just skipped the part that I was interested on. I think I put the debugger here, so. Oh, no, I think this is other stuff that I was gonna say that is maybe showing here the shaders, but I think that the call that ChatGPT said to do doesn't do anything. This one. It's not showing anything. So I think maybe the best thing to do is just to do it following the tutorials there. And try to do it from scratch and forget about Pixie. Because I think it's not going to be worth it to spend a bunch of time trying to figure out exactly what they use there. And then I should probably use the other library to simplify this stuff on... Or maybe I'll do my own functions. I have to follow the other tutorial actually to see how he simplifies the getting the variables and stuff like that. I think that this is the stuff that I mean, is that like inside of the graphics there's this draw circle function, and then the draw circle calls the draw shape, and then you create the circle inside of the draw shape. Like, that doesn't make sense to me, and I don't understand why they do it like that. Because of the stuff that I was talking about before. Like, it would make more sense to me. But maybe I think, yeah, the graphics make sense because it's the whole thing about the... But why not make it the same as the container? So instead of graphics, it could be container as well. And then you could have this stuff to create a circle in this function directly, instead of creating this one. To me that doesn't make sense, because like why call this draw shape if this name is draw circle and the only thing that this function does is call this other function? And I get that the draw shape is going to be a generic one and it's going to change depending on what you pass there, but it doesn't make sense to me. Like, maybe it's because of the way that people use it. So like, you can put directly here draw shape, because then it becomes more confusing for people to use it. But why not create, instead of creating this class here, create the function directly? Like, put the class outside here. It doesn't make sense to me. It also doesn't make sense, because why not call this one directly there? This is the stuff that I mean that I find it confusing. Because I don't really know if like it's because of there are other stuff that I don't understand about the context, or if it's just if it doesn't make sense. And it's hard because obviously like all the classes are connected, so, and the overall bigger picture of the way that everything is designed. This is a consequence of the way that everything else is designed, so this is why it's hard to know for sure. But I think it doesn't make sense. Like, I don't see a reason why doing like this. Maybe the problem with the way that I'm thinking about doing is this problem as well, that's we're gonna repeat a bunch of code, because to draw the circle you need to create these fundamental structures, like these lines here, and the matrices. So it makes more sense to have a generic one that is used on all classes. I think I have to create from scratch using the other one. And only after I do that, then I'm gonna be able to see if this is over complicated, more complex than it should be, or there's a reason behind this stuff. Blah, blah. So I think I'm probably gonna stop here because I already 3 hours, but I'm gonna follow these articles here. Maybe I should try to figure out. I just modify this one so that it works there. Because this is the main problem with this one. The other thing is that this is 3D. Oh, let me see. Yeah, I was spending this time because I trying to think about if there's a way to use Pixie there, but I think there isn't gonna be like a straightforward way to get the information from Pixie, the shaders that they use in the programs. So I think it's probably better to just try to modify these tutorials here, or figure out how to make the tutorials work. Because a lot of these tutorials are very good. They have a bunch of code that does exactly what I'm thinking about doing. The only problem with them is that they use a bunch of functions from different libraries that they create, and some of these functions don't work, and also they don't have a very good explanation. But I can just go over with the documentation or search somewhere else. So I think it might be... The problem with this approach is it's going to take more time because it's going to be harder. Because there's going to be a bunch of things that I'm going to have to figure out that Pixie probably already has solved. But maybe after I create something simple... The issue that I have as well is the stuff that I was talking about at the beginning of the stream, where it's kind of hard to think about a way to train myself to think about what is the best way to go about structuring things, because the tutorials already have all the code and it's just the explanation. So it doesn't really help you to think about, like, if I'm gonna do it from scratch on my own, what is the best way to reason about the structure of everything. I think that's the thing that I have to clarify more. Let me think if it's worth it spending more time here now on this stream, trying to figure something out or draw something. I can easily draw some simple thing just by copying a bunch of code from the tutorial, but the problem is that it doesn't do much for learning. And it's very easy, like I said before. Just have to create the shaders, and then you create a buffer, attach the data to the buffer, then use the program. The issue is, I think the main issue is figuring out what is the best way to think about structuring different programs. How many programs should you create? Should you do one program for each thing that you're gonna draw? Like, those are the questions I think it's very hard to think about. I'm not gonna be able to see from Pixie as well what exactly which one they're using. Maybe one thing that is worth trying is creating a program from these ones before I stop here. I think I'm gonna do that. I'm gonna do this, then I stop. And I'm gonna use the stuff that I already have there. And close the other files. The biggest issue is figuring out the... I think that's the main problem, figuring out the correct data formats and how to structure the buffer there. It's really annoying. Well, I don't remember if it has... Yeah, I think it just has the fragment. Okay, so one is the vertex, the other is the fragment. I think it's the 2 is the vertex. Oh, that should be source, I think. It's gonna create the shader from the string. So I think for creating this stuff, I'm not gonna do the complex or complicated way first, because I have to read the article again to understand what is the logic behind using or like using a bunch of functions to get the variables. So let me see if this one has the more simple way to do it. I'm gonna copy the canvas thing though. I think it's just resize canvas, but yeah, this part here. Those are the files that I have to change, because the way that they do it there is by using a script, so it works with this way of importing. I think I can make it work. Obviously I can make it work by just putting the script there, script tag, and it's gonna run the functions, but if I do it like it is now, it's not gonna work. And this is the part that it starts getting complicated, because it's hard to know like which things I should use, which things I shouldn't. Oh, this is inside of the... That's here. The two questions is how to create the buffer and how to structure the data to create the circles. And then everything else is pretty straightforward, I think. You just get the variables and set the stuff here. This part I still don't know really well. I don't understand really well. Like how is this connected with the shader? I think the reason why I don't understand really well is because I can't see the source code for this function here, so I don't understand. Like I don't understand when the GPU is drawing this stuff, how it's gonna use this information. But obviously what it does is just specify how it's gonna draw, but I think I'm just gonna copy the stuff I have here on the other one and then see how can I make it so that I use the... Oh, there's a difference as well, just remember. Because this is from one tutorial, this is from another. So maybe I'll copy this one. Let's see. So on this one, it sets the attribute inside. That's another question I had, which is what part to separate, like how to draw the line on the stuff that is going to be inside of the request animation and the stuff that is going to be outside. I think the last thing obviously is this bind buffer that it calls here. So it just creates the program Or maybe just copy this one and then I look at the other one to see what changes. So the difference here would be that here I'm gonna use the other function. I already have here. Yeah, so I guess the part that is sets the variables are inside of the thing here with the buffer. So the first thing that you do is just get all the variables. Then inside of the loop you create the buffer and you pass the data. And create the data and pass the data. And also you specify this stuff here. How is he using the... And these functions I don't know really well, so I'm gonna have to look at the documentation as well to understand more. But obviously each one is gonna be related to what kind of variable it is. And I think it's just gonna use the data to set the variable based on this. And based on which program is using. Creates the position, creates the buffer outside, then binds the buffer outside, and then. But why does it have this call here? I think this call probably is not necessary. I don't see why it would be, because you're setting the buffer here. So I think it makes more sense that the only thing you have to do. Maybe this is not. Maybe, yeah, I'm not really sure. But I think it would make more sense if this was outside as well of the loop. Because you're not going to change the program, but maybe you need... I think I remember seeing, reading something like that explains this on the tutorials, but I forgot. Turn on the attributes. I think I'm gonna go over the tutorials again off stream, and I'm gonna read about these functions on the documentation to understand more what they do. But I think that drawing the a simple stuff here is not gonna be hard, depending on obviously how hard it is to figure out what buffer to use and how to shape the data to create the circles. But any other, not any other, but other shapes that you can make with triangles that are easier to make with triangles is very easy to do, I think. It's not... The challenge is the stuff about the figuring out how to structure the shaders, how the shaders are connected, and how to create the classes and functions that are gonna handle, like they're gonna manage how the variables are going to be used. But I think what I'm going to do now is try to do this visualization with this stuff that I'm going to try to build as much as possible with the stuff from the tutorials, and maybe go back to Pixie later to see after building if I have a better understanding of why they decided to do it in the way that they did it. But I think it's very likely that I'm just gonna do this stuff from scratch here. And then I build the classes based on the stuff that I built here. And yeah, I think that I already have a clear idea on my mind on what I need to do. So the first thing is do the animation here, do the simple one. Then the second thing is create shaders and programs for each specific thing that I want to draw, which is just a ball or a circle and a line for creating the graphs. Then after I have that, I create the classes that are also I have to create the shaders and the programs to manage the road, I think, coordinates. And I have to see how they are going to be related to each other. Yeah, I think this is the main thing, is how to use the matrices and vectors to change the position of the camera and the road and how they are connected to each other. So the matrix stack one, I think that's the big thing. Then once I figure that out, then all I have to do is create classes that are gonna decide. Like I'm gonna create a container class that has in the same way that Pixie has, is gonna have it's gonna manage the shaders or in the programs for that particular part of the road, and I'm gonna try to copy that structure from Pixie, which is gonna be just a hierarchy. So you create a container and then you append the stuff that you want to draw to the container, and that create functions inside of that every time you change something on that container is going to change everything else, because they're going to be connected to that, the calculation of the matrices. And then I'm going to have functions to draw simple shapes. And then the container is going to call when I call the draw, and this is the biggest difference I think. I'm gonna just try to remove everything and just keep what is necessary. So the main thing that the container class, and I'm just gonna do one class I think as well, just a container class. So what the container class is gonna have is stuff to manage the children, to manage the coordinates of the world and the children, and is gonna have a function to draw the shape, which is going to be either a circle or a line. Maybe I'll do separate classes as well, just one for doing the... Yeah, but the problem is that in the way that it is structured there on the main code, I'm calling the draw functions from the container, and I think that matters a lot because that makes it a lot easier to synchronize the physics with the container. So I think that it has to be attached together, the function that manages. Maybe it is better to do another class of the one class that handles the circle and one that handles the lines, and then I just call that the class inside. The other one. And after that, I think that's pretty much it. And then everything else is gonna be like the events, and everything else is also gonna be part of the container, I think. Or I can attach to the canvas directly, and then I can put the functionality to change the stuff on the container in the same way that it already is there. Yeah, and then that should remove most of the stuff that I'm not gonna use. But I think that it probably makes sense the way that they did Pixie. It's just that the reason why I feel like it's not very good for what I'm trying to do is just because it has a bunch more stuff that I'm not gonna use, because what I'm trying to do is simple. So, but I'm gonna start here and with the simple thing, and then as I build, I'm gonna move more towards trying to reconstruct this. I'm trying to reconstruct on this project, and then once I have the classes that I think I'm gonna need, and everything, then I try to refactor the other project to use my code instead of using Pixie. And I'm probably not gonna use the React Pixie as well. I'm just gonna do everything on the normal React DOM, and maybe I'll change my mind later. Because actually I can use React Pixie because all I have to do is just change the, instead of initializing the app class, I put my own class there, and the rest is the same. So yeah, I create a class that is gonna contain this information that is gonna manage, but it's just gonna be a lot more simple than Pixie. It's just gonna contain this code here. Yeah, so I'm gonna read the articles again of String now and try to make the visualization work, and also understand more this connection of the hierarchy between them. So yeah, I'm not sure when I'm gonna come back, but probably soon, and I'm probably gonna continue to do this. But I think I'm gonna change the name of the title, because I don't think I think I'm just gonna move more towards doing my own thing, and I'm gonna try to mimic Pixie, like I said, but not rebuild. Just gonna do my own stuff. Let's see how, yeah, depending on how complicated it is, I go back to Pixie, but it's gonna be good learning process anyway, so yeah.